Okay, section 2.3 deals with the measure of the location of the data. This is going to be talking about quartiles, percentiles, that type of thing. Key terms right off the bat: quartiles. These are the 25th, 50th, and 75th percentile. Essentially, what it's going to be doing is we're going to have a list of data, and we're going to break it up into fourths. The first fourth is the 25th percentile, and then we get to the half, 50th percentile, and then the 75th percentile is the 3/4 mark, and then obviously our 100th. 100 percentile is that last piece, your maximum, essentially. Some just abbreviations: Q1 or Q sub 1, we call it 25th percentile. Q3 or Q sub 3, sometimes we call it 75th percentile. Q2 is the median or the 50th percentile. Median meaning middle number. Says in order to use percentiles in quartiles, the data must be ordered from smallest to largest or ascending. Quartiles divide the data into 4 quarters. Says percentiles divide the data into hundredths. So if you score in like the 85th percentile, that means that your score is better than 85%, equal to or better than 85% of the people who have taken that test. It means there's 15% of the people have done better than you. ACT tells you how you score. A lot of college entrance exams will tell you, how did you score against everybody else. ACT, SAT, that type of thing. Even if you dig into it, like your end of course exams, if you get into the Ohio Department of Education's website, and I'm pretty sure it tells you how you do compared to everybody else. One place that you'll see it, or maybe you have experienced this, is at the doctor's office, especially with little kids. Pediatricians will measure weight, height, head circumference, that type of stuff, and then they will compare that particular person to all of the collected data of all children, which is nice for parents to see. What is normal? Is my kid getting too big too fast? Are they not growing? Is their head oversized? That kind of thing. They can do so. What they do with that kind of stuff is, let's say your child, you think their head is just growing so much faster than the body, they look like a bobblehead. Comparisons of their percentile to the rest of the population can maybe ease some of your comfort or discomfort, and say, okay, well they're in the 60th percentile, so I guess it's not that bad. Okay, so their head is bigger than or equal to 60% of the population. But if it's in the 95th percentile, that means that it is bigger than 95% of measured circumferences. So which that might get the doctor to start thinking, okay, now why is this? Is this an abnormality? Is there a underlying health issue? That kind of thing. So these things are used frequently in a lot of different arenas. A lot of times with therapies, they will do standardized tests with people to determine their deficiencies, and then they'll go through therapy, and then they'll give them the test again, collect the data, and then compare that to the rest of the population and determine, okay, are they back to normal? Are they back to what's expected of them? And then adjust therapies per that. Median, number that measures the center of the data. Median may be thought as the middle value, but does not have to be an observed value. Okay, if we have a even number of data points in our sample, our median will actually be the average of the middle two values. So let's, for example, determine the median here. Now, you need to put these in ascending order. So what kind of stinks about the way I've kind of developed this is that there's some examples here that got some nasty numbers that we don't necessarily want to put in ascending order. Even these 11 numbers can be kind of a pain in the butt. So I'll show you a technique in Excel that will allow you to do this. All you've got to do is open Excel. Google Sheets has a similar function, but I'm just going to type in my data. It would be nice if We could cut and paste it, and that would expedite things, and usually when we're dealing with statistics, data is input and stored in spreadsheets like this for this purpose. So we've got 14 pieces of data. I thought I said 11, but looks like it's 14. Just to make sure I didn't do any twice. Okay. So all we're going to do is we're going to click on that data. You can either click the A and it'll select the entire column, or you can just click on A1 and drag down. But then you're going to go to the data column, and it should say sort. If you're expanded, it's this one here. Click sort. It's going to tell me what column do you want to sort. Well, I'll sort the one I just highlighted, so A. On the cell values, meaning the numbers that are in them, and I'm going to go small to large, just hit OK, and it sorts them. And that just makes things a little bit easier for us when we want to find then what our median is, what our 25th percentile or Q1 is, and so forth. So determining our median, what we're going to do is find, let's see here, we're going to find that middle value. Okay, so I like to just kind of count off this way, just cross them off until I get to the middle. And I get right here. And now, so what I've got going on right now, I've got 6 pieces of data above, 6 pieces of data below. So if I were to cross these two off, in the middle would be the median. Okay, so I'm going to take the average of those. So I take 6.8 plus 7.2 divided by 2. So that's going to give me 7. And you see there that that is not an observed value. Okay, which is fine. That's just the way it is. So we call that the median, or we call it Q2. Okay. The next thing I'm going to do is actually find Q1 and Q3. Okay, so this number here, 7, has now broken my data into 2 groups. It's broken it up into this group here, and it's broken it up into this group here. So now all I'm going to do to find Q1 is I'm going to do the same thing I did, and we'll find the middle value in this list here. So the middle value then is 2. Okay, so that's the median of the yellow piece of data. So Q1 is 2. And then come down here, and this piece of data right there is going to be the median of this upper half. So that is Q3. So Q3 would be 9. Pretty straightforward, pretty simple process for finding those values. Alright, so once we obviously find the median, then it talks about the quartiles, which we did. So to find Q1, you first find the median, and then find the median between the first value and the actual median. Says to find Q3, you find the median between the actual median and the last value. When doing that, just be cautious, because it can be somewhat confusing. When I found that 7, the true median, then that's the separating point for the data that I'm going to actually find Q1 inside of. So I don't include 7 as one of my points for my data values for this yellow list or this green list. We then want to find what we call the interquartile range, sometimes called the IQR, and that is just what we refer to as the middle 50%. And you find that by taking Q3 minus Q1. Remember, Q3 was 75%, Q1 was 25%. Subtract those, you get your 50%, and that's in the middle. The purpose of that is for us to be able to determine outliers. Remember, we said last week and the week before, an outlier can be identified through a distribution table. It can be maybe highlighted there, not necessarily identified, but gives us an idea that that data is unlike the rest. But using a word like it's just unlike the rest, or it's not close to the rest of the data points, is vague. So we need something more specific, more precise. So what we do generally is we take our interquartile range, multiply it by 1.5, and then we're going to subtract that from Q1, and then we're going to add it to Q3. And if we have any data that are outside those totals, then those are what we identify as outliers. And then if there's an outlier, we want to investigate that further. We want to talk about, especially if we're the research person. Obviously, if I'm just looking at homework problems, that kind of thing, we'll just identify it and move on. But if I was actually doing the research, I would want to make sure, okay, why is that an outlier? Did I do something wrong in collecting the data? Is it a typo? Is there something going on with that particular person, with the trait or the characteristic that we're trying to measure? We would look for a further investigation of that. So we'll do a couple examples here of dealing with the interquartile range and outliers and that sort of thing. So right here, list of numbers again. Again, not great numbers, so I apologize for that, but I will throw these in Excel real quick, and we will sort them. So let's see. I haven't figured out where the erase button here to clear all this stuff on Excel is. Alright, so let's type these in. So I'm going to pause it and do that so you don't have to watch. Okay, so I've typed that set of values into this array. Again, I'm going to highlight that. I can actually right click and go down to sort as well, and you can see that it obviously gives me then the options. I want to go smallest to largest, and there we go. We can look at, so we got 13 pieces of data. So if I look at that number right there, that's the middle value. So there should be 1, 2, 3, 4, 5, 6 above it. 1, 2, 3, 4, 5, 6 below it. So this Q2, which is my median, so Q2 is 488,800. Okay. Now I want to find Q1. So Q1 is now going to be, so if that was, that number right there was my median, now I'm going to look at this list here, and I want to find the median there. Now, if I look at this list, it's 1, 2, 3, 4, 5, 6. So it's an even number. So it's going to be the average then of those two. So I'll write that down. So Q1 is going to be 230,500 plus, it was the 387,000. We'll divide that by 2. Q3. Okay, so again, Q3 is going to be, this is the second half of my data. This was my median, so this is my second half. So then the median of that second half of data should be between those two. So we'll say 639 plus 659 all over 2. Alright, so we will calculate those. So just something that's nice with Excel, I can just say equals average, and it would have been those two numbers. Give me that average, and then I want down here the average of these two. That one's easy to do in your head anyways. So 308, 750, that's Q1, and 649,000 is Q3. Okay, so now when I want my interquartile range, That's taking Q3 minus Q1. Well, let's just do this here because all we gotta do is take this number minus that number. And my IQR now is 340250. Okay. So now if I want to figure out, are any of these numbers in this list an outlier? So this is how we do this. We take Q1 and we're going to subtract from it 1.5 times your IQR. See what that number is here in a moment. And then we'll take Q3 and we'll add to it 1.5 times IQR. So basically what this is going to do is going to put, if we've got our list of data here, okay, these two things are going to put a line here and a line there. It's going to be two demarcation lines that say beyond this, so the Q3 plus 1.5 times IQR is going to say anything beyond this to the right is an outlier. Anything beyond that to the left is an outlier. So when we do that, and again, I'm going to use Excel here just to kind of do the algebra for me. So Q1 was that 308,750 number. So that's in B4. And when I subtract from that then 1.5 times my IQR, which IQR was this 340,250 number that's in B12. And see what that gives me. So it gives me negative 201,625. Okay. Now I'm going to ask it to find Q3 plus 1.5. So Q3 was the 649 number, which is in B10. And I'm going to add to that 1.5 times my IQR, which was in B12. So it gives me this number, 1,159,375. And again, I'm using Excel. Excel is just a calculator, so if you want to get your handheld out, get Desmos out, you can do these calculations the same way. But now what I've got to do is, okay, if this is my list, then what this is doing ultimately is this negative 201,625 number is putting a line right here and saying anything above that line, or I guess if this was a number line that was horizontal, it would be to the left of that line. Anything that's smaller than that number of negative 201,625 is going to be an outlier. Well, there's no numbers above that red line or to the left of 114 or 114,950. Okay, the 1,159 number, so 1,159 would be in about right there in that area. Well, there are numbers that are beyond that. So you see what these IQR times 1.5 either added to Q3 or removed from Q1 kind of breaks up your data and says all of this data here is normal. This is not normal. Okay, anything over here would not be normal. So this 5 million number, what we're saying is it is an outlier. And then we would want to investigate, okay, well, why is that an outlier? Okay, is it a typo? Did I put one too many zeros in? Was it a, this is 13 real estate prices. Was it maybe the rest of these were residential and that was commercial or something like that? So those are just things that we have to maybe investigate a little bit further. I'll let you navigate this next one on your own. Okay. This example here, just very similar structure. They're going to ask you, can you compare these two sets of data? Okay, so we'll go ahead and do this just for the practice. So my suggestion to you as I'm doing these things on Excel, you open it, you do the same thing. In these videos, just taking notes and watching isn't going to be enough. Actively participate, and it will make things so much smoother and easier for you when it is time for you to use Excel on your own. You've taken the time to already learn it a little bit. So again, I just want to sort these. So I'm going to click on column A, or again, just drag and highlight the numbers I want to sort. I want to right click, come down to sort, smallest to largest. Okay. So we've got 20 pieces of data. So if I look at these two right there, that means that I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 above. And then now down here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 below. Okay. So that means then that my Q2 is the average of 80 and 81. Okay. So right here, Q2, average of 80 and 81, 80.5. Alright, so now that breaks my data into two groups. I've got this top group, including that 80, and I've got this bottom group. And what we're going to try to do is we're going to try to figure out, okay, well, what is the median then of this green set of data? So we got 10 pieces. If I come here to where my cursor is right now, we should have, what, 1, 2, 3, 4, 5 below, and then there's 4 above. So I should be looking then at those two pieces of data. Okay, 4 above, 4 below. So then we'll look at the average of that. So 76 plus 69, we'll divide that by 2. And that will be Q1. Same thing down here then. We're going to be looking at, I believe it's going to be those two, because now there's 4 pieces of data. Oh, circled the wrong two. Those two. There's going to be 4 pieces of data there between the true median. Okay. And now there's 4 pieces of data below there. So then we're going to look at the average of those two. So Q3 is going to be 90.5. Okay. As you guys are working with these, I again, to save a little bit of time, I'm going to skip the second one. I think you guys can do that on your own. Put it in your Excel sheet here. Okay. The nice thing then is, once you have that, you can make comparisons. Okay, was the middle 50% any different in test A or class A than the middle 50% in class B? And then once we are able to distinguish, is there a difference, then we can start asking questions. Okay, well, what is the difference? Why is there a difference? Finding the Kth percentile. Let me see what time we've got going on here. Yeah, a little bit. Finding the Kth percentile says there are multiple techniques for this. We'll use this one. I think it's the most straightforward. I is referred to as the index, and that's called the position of a value. K is the percentile of interest, and N is equal to the number of data values. Okay. So part A here says if the index is a whole number, then the Kth percentile is the ith value in the data set. Okay, and we'll talk about that here in a little bit, but ith value just means it's a particular position in the data set. B says if the index is not a whole number, it says it rounded up and and record that value in that position. Okay, put it in there too many times. It says round it down and record the value in that position. average the two, and this value is the kth percentile. The kth percentile does not necessarily have to be a value that was observed. So what we're doing here is, if I want to find the 25th percentile, 50th percentile, 75th percentile, this would be a technique for doing that. We've got quicker techniques, finding the medians of those different sets of data, but let's say I want to find the 79th percentile or the 14th percentile or something like that. This is the structure that we would go through to do that. Okay. So here it says 50 statistics students were asked how much sleep they get per school night. This is round to the nearest hour. It says the results were given below. It wants us to find the 28th percentile. So this is the way that we would do this. We just say I is equal to K over 100, and then times N plus 1. Okay, N is the number of students. I don't know if I said that up here. N, number of data values. Okay, it's the number in your sample. So I got 28 over 100. K is 28. 28 over 100. Multiply that by 50 plus 1. So 28 over 100 times 51 gives me 14.28. Okay. Says now what we do. Okay. Remember I said if the index I is not a whole number, round it up, record that value, round it down, record that value, and then average those. So 14.28, round that down to 14. Okay, so then I is what we refer to as the 14th term. Okay, I is the 14th term right now. And when we go through here, you got, especially with the way this is structured in a frequency table, it's going to be, we'll spend some time on determining how do I know that's the value 6. And then if I round this up, it gives me 15th term. Okay, and we'll identify what the 15th term is. So because this is a frequency distribution table, it's saying that right now if I go, so I got a frequency, so really what this list would look like if I had the list of data, we would have 4, because there's 2 of them. We'd have 5, 5, 5, 5, 5, because there's 5 5s. Number of hours of sleep would be 6, so we got 7 6s. So 1, 2, 3, 4, 5, 6, 7. We got 12 7s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I'm not going any further, but then you would have 14 8s, 7 9s, 3 10s. But they just structured it into a frequency table a little bit easier for us to at least have the data. Maybe not to interpret it, but we at least have it better organized in this table. But what we mean by the ith term is that term right there is when I is 1. That term right there, I is 2. Index tells you what position you are in the list. So when it says the 14th term, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see that 6 was the 14th term. 15th term is that one. So 7. So 6 and 7 are the 14th and 15th term because I was a decimal. And now what we do is we average those, okay, and that ends up being 6.5 is the 28th percentile, okay? So that means 28%, let's phrase it this way. If I get 6.5 hours of sleep, 6.5 hours of sleep, I get more sleep or the same amount of sleep as 28% of the people that were surveyed here. It says find the 50th percentile. Okay, so think about the 50th percentile. That should be what the average. So we got 50 numbers, so it should be the average of the middle two numbers in that list. Okay, if I were to put this all the way through, but if I go, so 50th percentile will be I is equal to K, which is 50, over 100, and now we'll go 50 plus 1. Okay, so now we're going to go, that's 1/2 times 51, so 51 over 2, which is 25.5. So it tells us then we are going to round that number up, and we'll look at the 25th number, or sorry, 26th number if we round it up, and we'll round it down to 25th. So either way, we're going to look at those two numbers. Okay, the 25th term and the 26th term. Well, think about this. Let's go back to Excel real quick just to maybe see this a little bit easier. Maybe not. I was hoping I could see 50 terms here, but it's going to be kind of ugly to do that. But if I had 50 terms written out here, and I would come, so let's highlight, I can at least highlight up to 50 terms. So to do that, what this is telling me is if I highlight the 25th and the 26th term, right there, you're going to have 24 numbers above those. 24 numbers above those. And then you'll have 24 numbers below those. And what does that essentially tell us? Well, that allows us to find the median of our list. Okay. So what I would want to do up here is I would want to find the 25th data point and the 26th data point. Well, if I go through here, so this would be 2, 7, 14. So right here, so 14, and then this would be plus 12 would be what, 26? So 7 is my 26th number, okay, in this list. Count them out. So this was 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. You get the idea, that's 26. And I got that by just knowing, well, cumulatively, at this stage here, 5 would be the 7th number, because those two add up to 7, so the 7th number is a 5. These three add up to 14, so the 14th number is a 6. The 26th number, because that's the cumulative at the end of this class here, would be a 7. And the one before that would also be a 7. So the 25th term is 7, 26th term is 7, the average of that, 7. Okay. If I want to find the third quartile, so remember third quartile is 75. So 75 over 100 times 50 plus 1. So I get what? 3/4 times 51. Let's see what that turns out to be. Let's see here. Three-fourths times 51, 38.25. So we'll round that down to 38 and we'll round it up to 39. 38 and 39. So we're going to find those two terms. So 38th term. Okay, so running total here. So far this would have been 26. So then I'll add 14 to that. And that gets me to what, 40? Okay, so 26, 40. So that tells me that the 38th term would have been back 2 from this. So the 38th term would have also been 8. And the 39th term would have also been 8. So then the average of 8 and 8 is 8. Again, you can figure that out if you wanted to take this frequency and write this entire list out and then count to the 38th and 39th. But they're both going to be that 8. Here it says, let's suppose that we have 25 test scores ordered from lowest to the highest, such as these. So those are already lowest to highest. So what I want to do is I want to find the 90th percentile. So I'm going to go I 90 over 100. And now I've got 25 test scores, so this number here is going to be 26. It's n plus 1. So 0.9 times 26, see what that is. 0.9 times 26, 23.4. So we're going to round that. So this gives me 23.4. So we'll round this to 23, and we'll round it to 24. Okay, so if that's the 25th term, these are the two that are 23 and 24. So we'll take those two numbers, 98 and 99. We'll average those, and we get 98.5. 98.5 is the 90th percentile. We'll go 20th percentile. So we go 20 over 100. And then 26. So 0.2 times 26 gives me 5.2. So I round that to 5, and I round it to 6, and I go find the 5th term. So 1, 2, 3, 4, 5, and there's the 6th. So I'm going to take 62 plus 66, and I'll divide that by 2. So what's that going to give me? 128 over 2, so it gives me, what, 64? No, that's not right. Yeah, that's right. Sorry, 64. So 64th is the 20th percentile. So that means that a score of 64, if that's what I receive, I have done as good or better than 20% of the test takers. It says, what percentile does a value represent? Okay, so this is kind of working this backwards. So they're going to tell me, okay, you scored 64. What percentile are you in then? So this is the structure that we go for doing that. We order from smallest to largest again. It says x equals the number of data values counting from smallest to largest. Should be a t there. Up to, but not including the data value for which you want to find the percentile. It says y equals the number of data values equal to the data value for which you I don't know what was going on here when I typed this. For which you want to find the percentile. N equals the total number of data values. Okay. General formula here. X plus 0.5 times y over n times 100 equals k. And then we're going to round that to the nearest integer. So it says, using the data from the previous example, what percentile does the score 93 represent? And then we'll say, what about 61? Okay, so we'll do those two. So again, we're going to order them smallest to largest. So let me just come up here just to make this a little bit easier. We'll snip this out. All right. Okay. So we got them smallest to largest. Okay, it says x equals the number of data values counting from smallest to largest up to, but not including the data value for which you want to find the percentile. So 93. So we're going to count up to, but not including. So basically what I'm going to do is I'm going to say, okay, how many are there? So I don't want to count all those, so I'm going to use subtraction. I know there's 25 in the list, I believe, right? 25. So this would be 1, 2, 3, 4, 5, 6. Okay, so there's going to be, what, 19 before that? Okay. So x is 19 plus then 0.5, and y is the number of data values equal to the data value for which you want to find the percentile. So I want to find the percentile 93, right? Okay, so there's only one 93 in here. We're going to divide that by n. So n was 25. And then this 100 is going to take that to a percent. And that should give me the 93, or what percentile the 93 is. So let me get the calculator out. So we'll take 19 times 0.5, divide that by 25, and we'll multiply it by 100. That's K, so we round that to the nearest integer. Check the time here. So when I plug that in, I apologize, I had a multiplication sign here. So 19 plus 0.5 times 1, all over 25, times 100, 78. So a score of 93 means that I am in the 78th percentile, which means that I have done better than or the same as 78% of the people who have taken this test. If we do 61, so 61 is right here. So I'm going to, X, remember, is the number of data values counting from smallest to largest, up to but not including 61. So 3 plus, then we go 0.5. Now Y is the number of values, or data values, that are the same as 61. So there's only one of those. If they were asking me like 69, there'd be 2, and that number would change to 2. And then we'll divide by 25, and then just change that to a percentage. So we get 3.5 eventually. I'll just put a 3 in here. We get 14. So if you scored 61, you were in the 14th percentile, meaning you did better than or equal to 14% of the people who took that test. Let's just do the 99 right here. Let's see what that kind of tells us. So 99, so up into, but not including 99, so there would be 23 plus 0.5 times 2, all over 25 then. So go 23. I'll just put 23 in here. But now it's plus 0.5 times 2. We get 96. Okay. So I would be in the 96th percentile if I scored a 99. Just a key thing here, if you get a decimal, just round it to the nearest integer. Usually don't say what was the 26.3 percentile, we just round that to 26th percentile. A couple other examples there I'll let you guys navigate through on your own if you need extra. Again, reach out to me if you need help with any of this stuff, need assistance, have questions, let me know.